But
yes.
I am Berta, and I am together with Alistair. I'm in charge of preparing the slides for tonight. What we are gonna do is we are gonna run a little bit through the material that is part of the Explore the Universe certificate for the RASC. So just to give a little overview, the Royal Astronomical Society of Canada has several observing programs so that for people of all stages of astronomy hobby journey, I guess. So for beginners, intermediate, and experienced. And so the Explore the Universe is a beginner's program. It doesn't require telescope. You can do it with binoculars. You can do it from the city. So we are basically gonna go a little bit through what's up to be seen in the sky during the month of May. That is listed mostly here in the Explore the Universe certificate. We have, so first we are gonna explain a little bit a couple of constellations that are up to be seen. Then we are gonna explain, Alistair is gonna go through the different International Space Station passes. Then we are gonna explain a little bit about what planets are out there to be seen right now. Then we're gonna explain a couple of features on the surface of the moon that are listed in the certificate. And then we are gonna do a brief introduction to double stars. What are double stars and why are they fun to observe? Because the Explore the Universe program has different things to see in the sky, and the last section is about double and multiple stars. So we are gonna start slowly introducing double stars. Now, that being said, we are in the time of year where the sunset occurs really, really late. Right now it's at 9, but actually the astronomical observing, it comes a little bit later than that because it has to get dark. So it's normally, I think, around 1 or 2 hours after that. And pretty soon the amount of dark time at night is gonna be reduced to pretty much 1 or 2 hours. So maybe here in Edmonton, during the months that are 1 month before and 1 month after the summer equinox, are months where basically you can do moon observing, solar observing, and I guess pretty much that's it because it doesn't really get dark. But there are a lot of interesting features like noctilucent clouds, and that maybe we should bring one day for this meeting. And then it's normally around the August when we are getting a little bit of dark sky back, so that we can start focusing on the features.
Thank you for the introduction, Berta. So she already said this. And, oh, well, no, I spoke too soon. There we go. So the International Space Station, watching satellites. We have loads and loads and loads of satellites crossing the sky. The International Space Station, or ISS, is the brightest one. And it's brighter than all of the planets except for Venus. So it's very bright and travels apparently like a high-flying aircraft in terms of how long it takes to cross the sky. And so the website heavensabove.com, which is linked when you come to the meeting web page, of all the links that are there, one of them is for Heavens Above, and you can get predictions for your own location. And I can see for here in Alberta, the evening passes are starting May 14th and heading on. And because the space station orbits every 90 minutes, and because the sun is not far below the horizon for us, it's northern latitude, we get to see 3, sometimes 4, and Bruce McCurdy has even managed to see 5 passes in one night of meteor observing. But oh, there's a space station again. And so this, you just click on any one of the blue links for the event that appeals to you. And typically what you're looking for is the highest point, both, well, time that fits your schedule, but highest point. And you will get a map that looks a lot like this. And this is one of the lower passes. And sometimes typically it starts low in the sky, moves up to high in the sky, and then back down low in the sky again. These charts will show you what's in the sky for your time. It'll also, for example, show you where the moon is, where the planets are, Mars in this case. And it's presented with south at the bottom. So this is a whole sky chart. And if you're looking straight up, you would essentially pick up the chart and look right up the middle, and you'd see the Big Dippers almost straight overhead in the middle here. So when we're looking south in the evening, we've got the bright star Regulus in the constellation Leo. And so those Regulus and Leo are two of the items you need to look for in order to gain your Explore the Universe certificate. So it's really easy to start. You just have to really print out the PDF. There's a link again on the website, and start filling out the forms. It's that easy. And then what we're also looking for is Spica down in Virgo. Virgo is really a constellation that you can appreciate more when you're out in the country, because the stars are typically much fainter. But Spica is the bright one here. And the way to remember and find these things is you start from the Big Dipper, which is overhead, and you get the handle of the bowl, and it arcs to Arcturus. So that's the nice orange, bright star in the sky. It's fourth brightest star in the sky. And that's very likely what our sun is going to end up looking like in about 6 or 7 billion years. So arc to Arcturus, and then spike to Spica. And no matter how the orientation is in the sky, it'll always have this pattern. So in early spring, you can actually guess where Spica is going to rise if it's not yet visible. You just sort of mentally in your head, arc to Arcturus, spike to Spica. Spica is a much bigger, brighter, massive star than Arcturus. It's actually 250 light years away. So it's pouring out a lot of light compared to Arcturus, which is actually pretty close to us. So that's one of the reasons Arcturus is brighter. And then shifting to north. So what you do is the chart, for example, that I posted on the website, if you print it and then turn it upside down, the north will now be at the bottom, and you then have to turn around and face north. And the Big Dipper is still overhead, but it's now the other way. And the Big Dipper is one of the first things we all learn is it points to the North Pole, or Polaris. And the other star, Cleomedes, is probably the other star that is most commonly confused with Polaris, and especially if it's just getting dark and the stars are just coming out of twilight, you can sometimes swap one for the other. They're fairly similar color and similar brightness, except Cleomedes has a companion, and so if your Polaris happens to have a companion, then it's not Polaris, it's Cleomedes. Polaris does have fainter stars nearby, but much fainter. And also the line from the bowl of the Dipper, the pointers, it's a bit straighter to get you to Polaris. Now, just a neat little interesting fact is that our planet, which spins with the North Pole up by definition, that North Pole hasn't always pointed in the same place. just like a child's spinning top. It slowly gyrates as it spins, and it takes 26,000 years to do a spinning cycle. And so when the pyramids were built, Polaris was way away from the pole, and the bright star Thuban was the pole star. And in between those two eras, the Kokab and its companion were closer to the North Pole. They didn't quite make it to being a polar star, but fairly close. And so they got called the guards. And I had always heard this expression, Kokab and its companion are the guards. And I never really understood what was meant by that. I thought, oh, they're guarding Polaris. And it's like, oh, no. It's 1,000 years ago, they were the closest bright stars to the pole. So they were guarding the pole. The other thing that's really neat when you start looking at the cultural origins of these things is that Ursa Minor, the little bear, no one's ever seen a little bear like this, for one thing, but is a relatively recent constellation. Back when the Greeks were first putting things together, they didn't really have anything for Ursa Minor. But more recent cultures, the Inuit called it Nuutituk. Don't think I quite got the pronunciation right. It turns out the translation is never moves. But with it being just about overhead from very, very high latitudes, it's not useful for navigation. If you've ever craned your neck looking up, your ability to actually figure out what is straight overhead versus what's high, you really can't do that very well. So they just realized, yeah, it's up there, but not useful for navigating. Farther south, the Cree nation called it Ikatchet, the going home star, which I find very reassuring. Gives me a nice warm fuzzy thinking about that. Okay, over to Berta.
Okay, so thanks, Alistair. As we said, the Explore the Universe is divided in sections. The first section is about constellations, and Alistair just explained a couple of constellations that are there. And if you go out and observe them, and observe the brighter stars in those constellations, you can tick them off in the list for Explore the Universe. So the next section is about the moon. So every month we are trying to feature one Maria and one crater of the moon and explain how to look for them with binoculars and a little bit of fun facts about them. So this month it's we're going to talk about Mare Fecunditatis, which is the Mare listed down there. This is a view of the moon as you will see it by eye, or better with binoculars. You can see already the Maria. If you look by eye, you see all these darker areas on the moon, but they really come to shine if you look at the moon with binoculars, and any binocular will be fine. You don't need big, heavy binoculars, just normal birding, the ones that you use to look for birds or something will be fine. And so that Maria down there that is pointed to with the arrow is Mare Fecunditatis. Just to give a sense of a scale, this Maria is in the widest part is around 990 kilometers in diameter at the widest point. And these Maria were formed at the very early stages of the moon. And it's when around 3.8 billion years ago, I would say plus minus, where at that time in the solar system, there were still big chunks of rock flying around, and they would impact on the surface of the moon and create these big areas that are like big craters that we call basins. And then they will also trigger volcanic activity So basically they will create a big crater that will get filled with lava from the volcanic activity triggered by the impact. And that's why the maria right now are a little bit darker, because they are filled with basalt, which is a rock that comes from the volcanic activity in the moon. Unless there is any question, we can maybe go to the next slide, please.
I clicked.
Okay, no worries. And then, because in the Explore the Universe, there are 12 different maria to be looking at, and 12 different craters. So today we are going to talk about Cleomedes. I guess that's how you call it, Cleomedes. This one is a crater that you can see when the moon is around 3 days old, which means that is three days, around 3 to 4 days have passed since new moon. That's when you start measuring the age of the moon, up to 28, which is basically full moon again. New moon again. So yes, 3 days old moon is basically the moon after 3 days after new moon. And so you can see this crater that is pointed, it's above Mare Crisium. Mare Crisium is the one, Crisium, the one that we talked about last week. And Cleomedes is this crater, round crater that is kind of big and is on top of that mare. And if you look at the moon with binoculars, you could actually see it. This crater is 126 kilometers wide. It's quite eroded. Erosion in the moon is not like here in the Earth that happens due to, here on Earth, the erosion happens due to the wind and the rain and, basically the passage of time and through all these atmospheric effects. But in the moon, there is no atmosphere, or it's certainly not as dense as our atmosphere, and they don't have meteorological phenomena. So erosion happens more due to impacts on the surface of the moon that are basically wearing out the previous craters. And so this one is a little bit eroded, so it's an old crater, and it does have some secondary craters inside. And if you can go to the next slide, please. This is a picture of that crater, Cleomedes, taken by the Lunar Reconnaissance Orbiter, which is a satellite that is going around the moon, or was going around the moon. I don't know if it still is. And it has photographed the moon in great detail. So you can see this big circle with little circles inside. So impacts had happened after. And so the circles inside have much sharper features than the big impact crater from Cleomedes. Thank you, Alistair. So next slide.
Trying.
And so the next, so we are the next section in the Explore the Universe is the solar system, which we are Alistair will talk later. But then the next after one is what we call deep sky objects, which is a bucket that holds a lot of different types of objects that one can see in the sky. From the city, open clusters, which is basically groups of stars that are gravitationally bonded. It's something that can be seen, and they actually are really beautiful to see, at least to my taste. I really like open clusters. And so cluster in Coma Berenices. Okay, Coma Berenices is a constellation that comes after Leo in in the images, if you remember the images that Alistair has shown at the beginning with the star charts, it's in there. It's a very tiny constellation. And so if you can see in this image is my understanding that Alistair took this picture, which is really pretty. So you can see all the background of the stars, but then you see these brighter stars on top that kind of fall like a waterfall, make this beautiful chain of stars going down. And so this large group, and that is the Coma star cluster. Okay, it's a star cluster that is part of the Coma Berenices constellation. And this large group of stars lies between Leo and Bootes. Bootes is the other constellation that Alistair has mentioned. It's made up of several chains of stars between 5 and 6 magnitude. So there is clearly seen by binoculars, and it's actually so big that you couldn't see it with a telescope. The best way to see this star cluster is with binoculars. And so it has a very beautiful legend associated to it. These stars that kind of fall like in a very graceful way and make this beautiful pattern in the sky is said to be the hair of an Egyptian queen, Queen Berenice. And her husband had to go to war, and she decided to shave her head completely and offer her hair to the goddess Aphrodite to ask for the safe return of her husband. So she put that hair as an offer to Aphrodite, and then the next day it was gone. So the astronomer from the court told her that what had happened is that Aphrodite had taken the hair and had put it up there in the sky, and had made that and created this beautiful star cluster that has such graceful shape. And it's really pretty to see from the city with binoculars, because the stars, they just make a very beautiful shape in the sky, I will say, to my taste. It's this constellation is known since classical times. Sorry, this star cluster is known since classical times, and it was previously known to represent the tail of the lion from the constellation Leo, but then it was promoted to be Berenice's hair. It is around 280 light years away from us, and it's great in binoculars, even from the city. So I really encourage you to get a star chart, go out and look for the Coma cluster with binoculars, and then if you find it, you can tick it off from your Explore the Universe program. Next one.
Okay, go ahead.
Okay, so after that, we are going to go to the next section of the Explore the Universe certificate, which is double stars. Now, it's the first time that we are introducing double stars in these talks, so I thought I should make a little introduction of what we mean by double stars. And so double stars are basically stars that if you look at them by eye, they just look like one star in the sky. But if you, as soon as you get your binoculars, or even better, a telescope, you can certainly see 2 stars and sometimes even 3 or 4 stars in there. Okay, and so there are 3 different types of double stars. The first one is what we call an optical double, which is just stars that happen to be aligned as we see them from Earth, but sometimes they can even be really far away from each other. They just, as it happens when we see them from here, they happen to be very close, but they can really, there is no relation in between them, and they can be even very far away from each other. Another type is what we call physical doubles, which are basically stars that are close to each other. And then there are what we call binary stars, which is actually stars that are related to each other in the sense that they do orbit around a common center or mass. So they're basically gravitationally bound to each other, and they orbit around a common center of mass. So in the Explore the Universe, for a lot of the stars, the double stars that are in the list, it tells you if they are optical, physical, or binary stars. And the fun thing to look at double stars is that sometimes they do offer interesting color and magnitude contrast. So for example, the stars here in the picture is one of the most famous double stars to be seen in the sky. This picture was taken by one of our members here at the Royal Astronomical Society in Edmonton, Abdur Anwar. And so this double star is Albireo. And as you can see in the picture, the star on the top is more of a yellowish color, whereas the star at the bottom, which is a little bit less bright, is actually kind of a bluish color. So when you look at these stars, especially with telescope or even with binoculars, you can start appreciating the strong color difference between them. And sometimes it's really difficult when you look at a star alone to identify their color. But when you see them so close to each other and having such different colors, the colors really jump at you. So it's a really beautiful pair to look at, for example, Albireo in the constellation Cygnus. So this double star is a summer star. So we probably can see it, I guess, later now in the night, or probably in August. It will be a good time to look for Albireo. And so to look at double stars, the only thing is that normally you need a good star atlas, such as the Pocket Sky Atlas, which is a paper star atlas, or you can use an app. For example, Sky Safari is a good app to look for. So you should look at them before you go out in the sky and identify them, because they're normally not listed in the small size star atlases. So today I'm going to highlight two of the double stars that are listed in the spring section of the spring. And if you go, for example, in a Sky Safari and you type 17Com, it will bring you to this star, because that's the name of the star. And so if you look at it in the chart that I have provided on the right of this page, you see it as a single star. That is the star pointed with the arrow, so it looks like just one star. But if you look, I've plotted the chart that I get with the Sky Safari. So as you start to zoom in on it in 17 Berenices, you already can see here in this chart that there are actually two, and one of them is much brighter than the second one. So that can be a fun challenge to go and look for that star and then identify it as the double star that you are looking at. It's kind of like a fun game of following the stars, or star hopping, as we call. And then the second one, it's a little bit, if the slide goes, yeah. The second one is much easier to find, and they are also a famous set of double stars, Mizar and Alcor, that actually some people can even see by eye. I personally don't, because my eyes are not that good, but they are in the tail of the Big Dipper. And for some people, they already appear separated just by eye. But if you look at them with binoculars, they are certainly apart, and Mizar is brighter than Alcor. So you can immediately see a change, different in brightness. And Mizar, it's a double itself. In itself, it's a double, but you need a telescope to see that. And so in this picture, taken again by Abdur, the astrophotographer one of the astrophotographers from the club here in Edmonton, you can see Mizar as being a binary itself, and then Alcor also being close. This is, of course, a very blown up image. It's taken with a telescope. And I think I'm done in my section, Alistair. So unless there is any question, I will pass the baton to Alistair.
Okay, thank you. Okay, and from the solar system part of the Explore the Universe certificate, they ask you to identify planets. And Mercury is, well, to use the word differently, is mercurial, which means that from the dictionary definition of it changes, and so what changes in particular for Mercury is it can be very difficult to see. It's often the last of the classic 5 planets for beginners to find, because it's just so tough. It's so close to the sun. But in spring evenings, Mercury becomes actually quite easy for a period of about 10 days. It's a little more of a challenge on either side of that 10-day period. But what happens is Mercury is, well, the closest planet to the sun. And so most of the time, well, it's up in the daytime, but of course the sky is bright, so you can't see it. And then it sets fairly early. But in spring, we get this situation where it sets the latest. What I like doing is telling people, actually, it's very much, it looks like a plane in the distance, but really in the distance. Whereas nearby planes, people can mistake Venus for, which is the brighter object down here. This is a composite of several nights, all taken one night after the other with a couple of gaps in there. The fainter one going up is Mercury. And so it's still essentially going to be the brightest star in that part of the sky, except it's not a star. And so there's really the trick to finding it is using binoculars first, and then once you latch onto it, then you can see it with the unaided eye, and then you can just the night after, the night after, the night after, just keep an eye on it, and you can follow it getting brighter, and then fading as it changes, as it gets as Mercury pops out from the sun and then comes in between us and the sun. It also has phases like the moon, and so it's changing from sort of more than half to a thin crescent by the end of May. And the spring, this is where it's hard to explain without full 3D graphics, but it's all complicated by the fact that we're on a tilted planet with respect to the solar system, and then we here in the north are even farther up the disk. Excuse me for the phone in the background. But in short, all you really need to appreciate at this point is that the path of the planets in spring is modestly steep, the way we're tilted with respect to the sky. And in fall, the path is much shallower. And so for this apparition, say here, look at the distance between the sun here and Mercury. And you sort of put that down. If you had the same situation, but in fall, it would be actually below the horizon. And I actually put Mercury in Venus's spot there. Anyways, on the website, I've included this table so that you can just download it. And these are the times for Edmonton, plus or minus, of course, in terms of they'll work well enough for Calgary or Fort McMurray. But yeah, as Berta had mentioned in the introduction, the light is staying around, the sun is setting late, and so the sky gets dark into modestly deep twilight by 10:15 in the evening, and it still gets later and later and later. And so what this table, what I've done is, because the sun is continuing to move north and the times are changing, I've created this so that it's the same time with respect to the sun, so it's the same level of twilight in the sky. And starting in, well, tomorrow, Mercury is barely above the horizon at 10:10 in the evening, and then it climbs rapidly up to one binocular field, and that's kind of a nice thing. So I think it's Sunday is we expect to get our next nice evening in here. Most binocular fields are about 7 degrees across. So if you point your binoculars at the horizon, put the horizon right at the bottom of the binoculars, and Mercury should be pretty close to being smack in the middle if you look at this time, almost 20 past 10. So it's going to still climb over the next few days. The greatest elongation, that's when it is the farthest in angle separation from the sun. So that usually gets a bit of press that, now's the time to go look for Mercury. And actually, the best time to look for Mercury is before greatest elongation, when it's a little bit brighter. But the greatest elongation is essentially right at its peak. So if you start going, as with most people do, I'll check on that in a couple of days. Well, it's already fading in a couple of days. It can climb a little bit higher, which means it's into the slightly darker part of the sky. So it kind of balances. So to our eye, it looks about the same for almost 10 days. And so it's, as I said, super easy. It's the brightest thing in that part of the sky. And it's off, well, in this case, to the northwest, west being 270 degrees and north being 360. So it's off to the northwest a little bit. But just look essentially where the sun, after the sun is set, you just sort of diagonally imagine this line and put your binoculars, which will have a field of view up to about here, and Mercury should be there, and it should be once you see it, you'll go, well, that's easy. What's all the fuss about how difficult it is? Because it's super easy. And then it's going to be tough now for basically the rest of the year until we hit October. And then it's going to be visible in the morning. So now's the time for Mercury. And I think that is that. So I'll stop the screen sharing, and we'll open up questions and that anybody has. Make sure you unmute yourself if you have a question.
Presentation, Alistair and Bertha, thank you so much.
No, pleasure having you here, Frank, and our regards to our fellow rascals in the Montreal Center.
Thank you. There's Mark.
There's Mark.
You're muted, Mark.
There we go. Thanks for the presentation, guys. Well done.
And as a reminder, 1 week from tonight, Jeff Robertson is doing his What's Up in the Sky for May. So he'll be talking about among other things, a little bit about Mercury, a little bit about the lunar eclipse, what else is going on, and what happened in space history this month, years ago. And sad note, Michael Collins died today.
Oh.
He was the commander of the Apollo 11. Yeah, so.
Is it always the same link? Your meetings are Wednesdays at 9:30 with the same link?
That's right, yes. Yeah.
Okay.
Thanks very much, Alistair and Berta. I haven't sat in on one of your sessions before. And for one who always just uses plate solving and to get you to where you want to go, it's always a breath of fresh air to look up and say, okay, yeah, this is what I should be doing. So thank you.
You're welcome.
It's a pleasure.
Yeah, and one more thing. The Eta Aquarid meteor shower is coming up, so that's bound to get a lot of press as usual. And the press is typically a bit overhyped. but because it'll be, dazzle the skies with electric fireballs and whatnot. And of course, it's not quite the case. It really depends on where you live in the world. Like they'll say up to 20 meteors per hour. If you live on the equator, yes, but at our latitudes, we don't get to see much about the 8 Aquarids, and it's right as dawn is breaking. So we only really tell people around here, only go for the 8 Aquarids if you just really like being up near dawn and out in the country where the birds are chirping. It's a lovely, relaxing way to just look at the sky, and every now and then, and you might only see 2 Aquarids during a 1 hour watch of the sky, but it's very peaceful, and spring dawn is just fantastic out in the country. So it's highly recommended for that, but meteors are just a complete bonus. Oh, you're muted, Jeff.
The moon is in the sky. It's a waning crescent at the time, but like you say, it's an early morning thing, and not all that spectacular from our latitude. However, it's on my agenda.
Oh yeah. I always feel a little bad sort of downplaying an upcoming interesting astronomy event, but it's when it's not good for the general population to think that they're going to go outside and see Hollywood fireballs crossing the sky in an electric performance.
Yeah.
Nope.
Yeah.
A bit like the supermoon, So, yeah.
Yeah. One of the things, just thanks, Mark, about the supermoon we just had and the one we will get again. It's I think it was I don't pay attention to these things at all, other than when I look at the moon about 2 or 3 days ago. It's like, oh, that looks a little bit bigger than usual. And it's like, yep, our close approach is 3 days away, so it does look a little bit bigger in the sky. But when it's all alone there in the sky, it's not easy to tell that it's bigger or smaller or average.
Yeah, and it was a super pink moon, but both Josh and the other guy in Global kept saying it won't really be pink, but because the main full moon is the pink, one of the names is pink moon. Well, so they kept going super pink moon, but it's not really pink.
Well, the one that will be that is the right color is the honey moon in June.
In June, yeah.
Because it stays very low in the sky, and so typically it is a little on the yellower side. So that's about the only one that makes sense from that perspective. Okay, well, if there's no more questions, we'll bid you a good evening. Thanks for joining in, and hope you found it useful. And just the last reminder, a lot of links on the website for the meeting to download your Explore the Universe logbook and go for that certificate. And pleasure seeing some new and old faces. Okay, good night, everyone.
Thank you. Good night.
Good night.